In this set of examples, we're going to give you some transformations. We want you to rewrite the equation and then graph it. So here's our first example. What we give you in this parent function is the shape of a quadratic equation, which is going to be a parabola. That parabola has a critical point of 0, 0, which we call the vertex. Now there's two transformations. One is a horizontal translation to the right 3, and then a vertical shift up 4. So to rewrite this function with the transformations, we're going to go inside the function minus 3, which you got to think opposite, and then outside the function at the end plus 4. So now we've created our new function after its transformations, and now let's identify the critical point. Right 3, up 4. So let's graph this first point. It's critical point 3, 4. And now let's pick a value to the right and a value to the left of that x value being 3. So we're going to pick 4 and 2. And we're going to evaluate it for this g of x function, x minus 3 all squared plus 4. So we substitute 4 in for x, so 4 minus 3 all squared plus 4. 4 minus 3 is 1, square root is 1, add 4, and we get 5. Now we're going to go 1 to the left. So 2 minus 3 squared plus 4. 2 minus 3 is negative 1, squared is 1, add 4 is 5. So our next to order pairs is over 4, up 5, and over 2, up 5. We're going to pick one more right and left of that. So we'll pick 5 and 1 and evaluate it. So 5 minus 3, all squared plus 4. 2 squared plus 4. 2 squared is 4, plus 4 is 8. We should also get 8 here if we evaluate it. So over 5, up 8, 6, and then 8. Over 5, up 8. Over 1, up 8. You should see that symmetry there. So here is our function graphed out with its transformations. Our last example now is an absolute value function. There are two transformations. Remember, the shape of that absolute value function is the shape of a V. Its critical point will be 0, 0. And we want to horizontally scale it by a factor of 2. So that's going to be inside the function. We have to think opposite. We're going to reciprocate that 2 as 1 over 2. The other thing is a reflection about the x-axis. There's going to be a negative in front of the function. So to rewrite the function, we put a negative in front, and then the absolute value, x, and now we're going to go 1/2 inside the function. Our critical point, we did not move left or right at all, so our critical point stays the same as 0, 0. So let's graph that critical point, 0, 0. Now we're going to pick a number to the right and one to the left, 1 and negative 1, and evaluate the function. So again, we're evaluating it for the new parent function, or the new function, like that. So negative absolute value 1/2 times x, which is 1, negative absolute value 1/2 is negative 0.5. Negative 1/2 with a negative times 1, absolute value of negative 1/2 is still 1/2 with a negative. So we graph those over 1. Down 1/2. And over 1 to the left, down 1/2. Now we'll try one more right and left. So we'll go 2 and negative 2. Evaluate the function, so it's negative absolute value 1/2 times 2. Negative 1/2 times 2 is 1, absolute value of 1 is 1, and you get negative 1. Should get negative 1 also on the second one because of the symmetry. So if we graph those, we're going to go over 2, down 1, and then left 2, down 1. So that's what our graph should look like.